Now that you've seen what Vault can do, let's take a closer look at how it actually works behind the scenes. ToolVault is an open source plugin, so you're free to inspect the code yourself at any time. But since it's a large and robust plugin, built to handle many real-world scenarios and edge cases, we thought it would be helpful to give you a high-level overview of how it works. In this video, we'll walk through the structure of a Moodle site, compare manual and automated migration, and show you exactly what happens during a backup, restore, or upgrade using Vault. Let's take a quick look at the structure of a typical Moodle site. A Moodle site is made up of several key components. The codebase, which contains all the Moodle code. The data directory, where Moodle stores things like installed language packs, the persistent cache, and some other types of data. File storage, which includes files uploaded by users and generated by Moodle. The SQL database, which holds all your Moodle data, users, courses, grades, settings, and more. And finally, there's a temporary directory. When you install Moodle plugins, they're added to the same folder as the core Moodle code, the codebase. Inside this folder, you'll also find the config.php file. It holds important information passed through the data directory and file storage, and the database connection credentials. There's also a cron process running on the Moodle server. It handles scheduled tasks and long-running ad hoc tasks, and is essential for Moodle to function correctly. All these components don't necessarily live on the same server. They could be on different partitions or even on entirely separate machines. By default, file storage is located inside the data directory, but it can be configured to use external storage like Amazon S3 or Microsoft Azure. And finally, when you access your Moodle site from the web browser, you're always accessing files inside the codebase. It's important to note that no user-submitted content is stored in the codebase, and you can't directly access the data directory, file storage, or database from the browser. Instead, the PHP scripts inside your Moodle site access all the necessary data. In fact, only the data directory is accessed directly by the code. File storage is accessed through Moodle's Files API. This abstraction allows plugins and core code to work without knowing whether the files are stored locally or in the cloud, like Amazon S3 or Azure. The same principle applies to the database. Moodle uses a data manipulation language, which means core features and plugins can work across different database engines without needing to know the exact type, whether it's MySQL, MariaDB, or Postgres. Even when no one is actively using your Moodle site, the cron still runs every minute. It executes a special cron script located in the codebase. Cron runs directly on the server using the command line interface, or CLI. This is important because browser-based requests have strict time and memory limits, mainly for security. When cron runs in the CLI, those limits don't apply in the same way. It can run longer tasks and use more memory. Now that we understand the structure of a Moodle site, let's look at how you would migrate a Moodle site manually. You have two servers, a source and a target, and you want to move your Moodle site from one to the other. The first step is to transfer the codebase. You can either copy it directly from the source server or download a fresh copy of Moodle and reinstall all the plugins on the new server. Be careful not to copy the original config.php file. Instead, create a new config.php file on the target server that points to the new data directory and database. Next, you'll need to copy all the files from the data directory. Then do the same for the file storage. You can use a command like scp to copy files over the network, but that can be very slow as it transfers files one by one. Alternatively, you could archive the files into a single large file, transfer that, and unpack it on the target server. But these archives can be huge, potentially hundreds of gigabytes, and may be hard to move reliably over the network. To copy the database, you first need to run a command like mysql dump or pgdump to export the entire database into a single file. Then transfer that file to the new server and use it to recreate the database by running the SQL command from the dump. But keep in mind, a MySQL dump can only be restored into another MySQL-based database. And the same goes for Postgres. You cannot use a dump from one engine to restore into another. As you can see, this process is quite demanding. You'll need SSH access to both servers, the ability to run CLI commands, access to database tools like MySQL dump or pgdump, and a reliable way to transfer large amounts of data across servers. And if you're trying to send a site backup to someone else, that's a whole other challenge. You certainly can't just email them gigabytes of files in database dump. That said, when everything goes smoothly, this traditional method is faster than using Vault, but only if you get everything right on the first try. Now let's see how to migrate a Moodle site using Vault. On your source Moodle site, the first step is to install the Tool Vault plugin, just like you would with any other Moodle plugin. Once it's installed, go to the web interface, open Vault Site Backup and Migration, and request a site backup. At the next cron run, Moodle's cron process will execute a script from the Tool Vault plugin. It will automatically put your site into maintenance mode and begin the backup process. First, Vault reads the structure of your database using Moodle's Data Manipulation Language API. It saves this information in Moodle XML format. It also adds essential details about your site, like the list of installed plugins and their versions, and uploads this metadata to the cloud. Next, Vault reads the data from each database table one by one. It archives the data and uploads it to the cloud. If your database is very large, Vault splits the data into several archives to keep the temporary storage usage low and the individual archive sizes manageable. After that, Vault moves onto the data directory. It automatically reads all files there, skipping any directories used for caching. The files are archived and uploaded to the cloud. Sometimes, especially if you don't have any language packs, there won't be any files in this directory, and this step will be skipped. Finally, Vault accesses every file in file storage one by one through the Files API. These files are added to the archive and uploaded in chunks, so you may see multiple archive files here as well. And that's it, your backup is complete. Just a quick reminder, the backup created by Vault includes only the data from the data directory, file storage, and the database. The code base and the code of any add-on plugins are not included in the backup. So, how do you restore a backup? You can restore it yourself or share your API keys with someone else to restore it in a different location. First, set up a fresh Moodle site at the new location. Configure to use the new data directory, file storage, and database. You can use any username and email address for the admin account. These will be overwritten during the restore process. And don't forget to set up the cron job. Next, install the code for all the add-on plugins you need. Remember, the backup does not include any code, only data. Of course, you also need to install the Tool Vault plugin. Finally, go to the Vault settings and enable restores to allow the restoration process. When everything is ready, go to the web interface, enter your API key, and request a site restore. At the next cron run, cron will execute a script from Tool Vault to start the restore process. First, Vault downloads the database structure file and extracts it into the temporary directory. It then runs several pre-checks to make sure the backup can be safely restored. For example, it checks that there's enough space in the temporary directory, confirms that your Moodle version is the same or newer than the backup, and verifies that each add-on plugin has the same or higher version than what was in the backup. If some plugins are present in the backup but missing on the target site, the pre-check will flag a warning, but this won't stop the restore from proceeding. For example, let's say one of the add-on plugins is missing on the target site. After the pre-checks, the restore begins, essentially reversing the backup process. Vault begins with the database restore. It downloads the archive files and inserts the data into the database tables one by one. This is a critical step. If the restore is interrupted midway, the database may become inconsistent and your Moodle site won't function properly. In that case, you'll need to reinstall Moodle and start the restore from the beginning. Once the database restore is complete, Vault moves on to restoring the data directory. Finally, it restores all the files. These files are added through Moodle's Files API, which means the process works seamlessly whether you use local storage or cloud storage. This last stage is usually the longest. Vault keeps track of the progress, so if your cron job times out, or if you lose power or internet during the restore, the process can be resumed later. And just like that, the restore is complete. Remember, your user table has been replaced with the one on the backup. This means you'll need to log in using the admin credentials from the original site. And once again, only the data directory, file storage, and database were restored. This means your code base may not be fully in sync with the restored data. If your Moodle or plugin code versions are higher than those in the backup, you'll be prompted to run the upgrade process to bring everything in line. If the code for some add-on plugins is missing, Your database and file storage will still contain the data for those plugins. However, without the code, Moodle can't use that data. These plugins will be listed in the plugins overview as missing from disk. You have two options. You can either copy the missing plugin code into your codebase and Moodle will recognize the data, or you can run the uninstall process to remove all data related to those plugins. Vault can automatically run the upgrade process or uninstall missing plugins during the restore. However, Vault cannot install the missing plugin code for you. In many cases, PHP scripts don't have permission to write to the codebase directory, so you'll need to add the plugin code manually by other means. By the way, don't forget to check the settings of the Vault plugin. It has some other handy features. For example, if you have plugins that manage server-specific environments, like file storage or cache, Vault can exclude these plugins from the backup or restore process. And as I mentioned earlier, it can automatically run the upgrade process or uninstall missing plugins for you. Let's take a moment to talk about the upgrade process. As you probably know, Moodle has specific requirements for upgrades. You can only upgrade across about 4 or 5 major versions at a time. To visualize this, imagine a table showing the upgrade paths. For example, from Moodle 3.9, you can only directly upgrade to 4.1, then from 4.1, you can upgrade to 4.5, and only after that to 5.0. When you factor in changing PHP version requirements, upgrading an old Moodle site can become quite complicated. Currently, Vault supports Moodle versions from 3.9 and above. We plan to add support for earlier versions as well, at least for backups. With Vault, after you restore your site, you can upgrade from any supported Moodle version to any other supported version in a single step. For example, it can upgrade a Moodle 3.9 site directly to 5.0, no intermediate upgrades needed. That's a look behind the scenes at how Vault works. From understanding the Moodle site structure to performing full backups, restores, and upgrades. Whether you're migrating, recovering, or upgrading, Vault takes care of the heavy lifting and helps you manage your Moodle site with confidence. Thanks for watching, and we hope Vault makes your Moodle operations easier and more reliable.